Hello, good evening, everyone. Good evening, sir. My topic for today is all about the introduction of neutral geometry. So, we all know that our past discussion we tackled about the Euclid's geometry. So, Euclid's geometry is all about uh, the geometry that tackles only the properties nga kanabitang masettle siya within the plane or the parallel lines. So, in this case, neutral geometry, it is the the out of the box of the Euclid study. So, how about the curves, the hyperbolic, mga ana ba nga nga wala siya na cover sa Euclid niya study. So, let's move on and tackle this discussion. So, let's go. So, let's know what is geometry. So, we all know what geometry is. So, let me read the meaning or the definitions of the definition of geometry. So, it's the ancient Greek. Geo means earth and measurement. So, it's the measurement of any things in earth. So, it is a branch of mathematics that is primarily concerned in shapes and the objects and their positions and their properties of space. So, there are so many postulates and theorems applied by the Greek mathematician Euclid. So, when we tackle about the Euclid's postulate or the Euclid's geometry, so but we will tackle today is all about the neutral geometry. So, yung mga hindi na covered ni Euclid. So, it is the branch of mathematics as what I've said. Then there are so many types or related concepts ng geometry. So, it is categorized under the three types. So, we have the Euclidean. So, ito yung mga planes or yung mga nakaparallel lines, di ba? Sulod sa or it's in the what you call this? It's in the elements, or di ba? Postulates elements, book of elements, the Euclidean and we have this hyperbolic. So this is a neutral geometry and elliptical geometry. So another neutral geometry din ito siya. So it is example, we have this Euclidean, no? Ito siya. Let me do icon. Let's go back. So Euclid, okay. Pen. So ito Euclidean. So all of the angles of the Euclidean geometry is equal to 180 degrees. So that's the Euclidean geometry. So in a spherical or the hyperbolic or elliptical space, it another example ni siya sa neutral geometry. So the angle A plus angle B and the angle Y, or the angle is equal to greater than 180 degrees. And also we have this hyperbolic, which is all of the angles is greater than 180 degrees. So Euclidean geometry. So ito, the Euclidean geometry is right angle is equal to 90 degrees, and the elliptical geometry is less than 980 degrees. So ito, less than 90 degrees. And the hyperbolic also, we have greater than 90 degrees. So ito siya. So but our focus in this discussion is all about the neutral geometry. So ito. So let's go. So what is neutral geometry? So the neutral plane geometry, it is the geometry without a parallel line axiom. So ang parallel line axiom is, it's a Euclidean geometry. So, di ba? It is built up of some incidents, containment, and axioms. Betweenness axioms, congruency axioms, and one important axioms about triangles. So these axioms are in addition to the standard assumptions of logic. So undefined quantities include points, lines, sets, etc. So neutral geometry is kung ano yung mga hindi na cover or hindi kayang ma-explain, hindi kaya ma-explain ni Euclid, but out of the box of Euclid's topic. So dito napunta sa neutral geometry. So along with the discussion of my classmates, you will know what is neutral geometry, how they work, how they calculate, how to measure. So ayun siya. Doon yung malalaman. So what is the purpose of studying neutral geometry? So, the purpose of studying the neutral geometry is very simple. We are not interested in studying for its own sake, so rather we are trying to clarify. So we are just trying to clarify what are the reasons behind of that a geometrical problems or any logical na mga nga situation nga dili makaya or kana bitaw out of the box of Euclid's topic. So it is to clarify the rule of the parallel postulate by seeing which theorems in the geometry do not depend on it. So rather we don't need the Euclidean geometry. Pasok siya sa theorems and axioms of the neutral geometry. So in that case, dili na ta maka manlibog pa kung unsa man ato mga kung unsa ang lessons or kung unsa ang mga answers when it comes to geometrical problems. So that would be my part. So along of this discussion, I will tackle or by my group mates of how to measure or what is neutral geometry talaga.
Hi guys, this is Joanne B. Campredondo from Group 2 Neutral Geometry.
In this video, we'll talk about the exterior angle theorem. So without further ado, let's do this topic. So what we have here is first, we will define the exterior angle theorem. The exterior angle theorem states that the measure of an exterior angle is equal to the sum of the measures of the two opposite remote interior angles of a triangle. So what we have here is a given illustration of a triangle with an exterior angle. So as you can see, this angle E is your exterior angle, while A, B, and C are the interior angles of a given right triangle, Now, ang ibig sabihin ng ating exterior angle theorem states here that the measurement of this exterior angle E is equal to the sum of the opposite or the two remote interior angles. So what we have here, these are the two remote interior angles. So to find the measurement of an exterior angle, what you need is this equation. Exterior angle E is equal to the sum of the two remote interior angles. That is angle A plus angle B. So let's put to practice para mas maintindihan nyo paano ba ginagamit yung concept about exterior angle theorem. So what we have here are three examples. Find the measure of each indicated angle. Here, we have triangle DEC, and the given, or the missing angle here is angle DCG, in which this angle DCG is an exterior angle. So we will find this one. We have angle DCG. Para malaman yung value nito, we need to add the two angles that is equal to the angle EDC plus angle CED. These two angles, this one and this one, are the two remote interior angles. Substitute the value of EDC is 70 degrees, plus your CED, which is 24 degrees. As you can see, the value of angle DCG, which is the exterior angle, is simply 94 degrees. This is 94 degrees.
Let's look at the parts of an angle to start. This angle has two rays, ZA and ZU, meet at point Z. Where they meet at point Z, they form a vertex, angle Z. We say rays ZA and ZU, but those rays could also be small snippets out of longer lines that intersected at point Z. Parallel lines never meet. The two lines, line segments, or rays never converge or diverge. Parallel lines can be intersected by transversals. Any line cutting across parallel lines is a transversal. It can cross at any angle. A transversal intersecting parallel lines at 90 degrees is perpendicular. When a transversal intersects parallel lines, it creates an interior and exterior. When the transversal intersects, it creates 4 angles at each parallel line, or 8 angles altogether. 4 of those angles are exterior, and 4 are interior. Those are our alternate interior angles. Let's create parallel lines LI and ON, and a transversal HE. The 2 points where HE crosses the parallel lines are points A and R. You mark drawings of parallel lines with little bird feet marks, like V's on their sides. Notice we have 4 exterior angles: angle HAL, angle HAI, angle ORE, angle NER. And we have 4 interior angles: angle LAR, angle IAR, angle ARO, angle ARN. Today we are only interested in the 4 interior angles. 2 of the interior angles are built using the top parallel line LI, and 2 are built using the bottom parallel line ON. Alternate interior angles are 2 congruent angles from different parallel lines, one from LI, one from ON. This says angle LAR is an alternate interior angle with angle ARN, and angle IAR is an alternate interior angle with angle ARO. You can use the alternate interior angles theorem to speed up your work. The alternate interior angles theorem states that if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. The converse of the theorem is also true. The converse of the alternate interior angles theorem states that if 2 lines are cut by a transversal and the alternate interior angles are congruent, then the lines being cut by the transversal are parallel.
Hello, this is Rosel B. De La Cruz, and we're going to tackle about the measurement of angles and segment. And now we're gonna find the measure of angle X, Z, and Y. Since X is up against the wall, straight line I mean, it can create an arc or half of a circle which is equivalent to 180 degrees, and that's commonly known as supplementary angles. So all we need to do is subtract the 139 degrees to 180 degrees, which is 41 degrees, and that is the measure of angle X. Next is the angle Z, opposite angle of X, or also known as vertical angles. And when we say vertical angles, it means congruent. So the measure of angle Z, 41 degrees, is the same with angle X. The last is angle Y. To find the angle Y is to add 41 degrees and 49 degrees of a total of 90 degrees. Then subtract 90 to 180. Subtract to get the measure of angle Y, which is 90 degrees. And now let's move on to the measure of segment. We have here find segment lengths. How can you find the length of segment CD? You can simply count the distance between CD or do the other way around, right? Right, 4 minus 1 is equals to 3 units. Or 1 minus 4 inside the absolute value, since there is no negative distance. So it's still positive 3. Oops. Still positive 3 units. Now let's find the length of segment AD. The same solution, you can count or just write 8 minus 1 is equals to 7 units. For absolute value, 1 minus 8 is the same outcome, 7 units. That's all, thank you.
Hello, good day everyone. By the way, this is Leslie Safrahenko. And now, let us talk about Zachary-Legendre theorem. And this is an example of Zachary-Legendre theorem. If triangle ABC is a triangle and E is the point interior to the segment BC, then sigma triangle ABE plus sigma triangle ECA is equal to sigma triangle ABC plus 180. Note that in interior to angle ABC so that we can add angles. Thus, measured angle BAC is equal to measured angle BAE plus measured angle EAC. Moreover, angle BEA and angle CEA form a linear pair. So, measured angle BEA plus measured angle CEA is equal to 180. Now, the sum of sigma triangle ABE plus sigma triangle ECE is the sum of 6 angles. Measured angle ABC plus measured angle EAB plus measured angle EAC plus measured angle BEA plus measured angle EC plus measured angle ACB is using that above we get. And now we have here sigma triangle ABC plus sigma triangle ECA is equal to measured angle ABE plus measured angle BAC plus 180 plus measured angle ACB. In other words, we have sigma triangle ABE plus sigma triangle ECA is equal to sigma triangle ABC plus 180. That's all. Thank you.